So our first lesson will be about variable and verbal expressions. And before actually doing some problems, I'd like to introduce some key vocabularies that you would associate with some mathematical operations. So here we have addition, and you would use put together, combine, plus, sum, or increase by. And there are many other vocabularies that you could associate with these operations, but those ones are the most common ones. And for subtraction, we have minus, difference, less than, and subtract from. Note that less than and subtract from, there are stars next to them. It's because the orders, when you actually writing them out, will be the opposite. And you will see when we actually do some problems. And for multiplication, we have times, product, and equal groups of. And for division, we have divided by and quotient. And so I'd also want to introduce some other vocabularies with regards to Algebra 1. So we have a variable, which is a letter or symbol that is used to represent a value that can change. An example would be x, y, and z. We use x and y the most often in Algebra 1. Don't really know why, but that's what it is. And for constants, we have it is a value that doesn't really change. An example would be 3, 4, or pi. Pi is basically just 3.14, so it is a constant, and it's not a variable. For numerical expression, it can contain only constants and operations. Such example would be 3 plus 4. An algebraic expression may contain variables, constants, and operations, such as x plus 3. And we also have this PEMDAS here. I'm sure most of us are familiar with PEMDAS. P stands for parenthesis, E is exponent, multiplication, division, addition, and subtraction. This is basically the order how you will do a problem. And for multiplication and division, the order does not matter. Whether it's, let me write an example, like 7 times 1 divided by 2. You can do 1 divided by 2 first, and then multiply it by 7, or just 7 times 1, and then divide the product by 2. And it's the same for addition and subtraction as well. You can have 3 plus 4 minus 2. You could do 4 minus 2 first, or 3 plus 4. 3 plus 4 is 7, minus 2 is 5. Or you could do 4 minus 2, which is 2 plus 3 is also 5. It gives the same answer. So the order of those don't really matter, but the other ones do. Let's actually do some problems. And the first problem, the difference of 10 and 5. Difference subtract, so it's 10 minus 5. It only wants us to write it as algebraic expressions, so we don't solve those. The quotient of 14 and 7, 14 divided by 7. U decreased by 17 as u minus 17. Half of 14, 14 over 2, or you could write it as 1/2 times 14. It's the same. X increased by 6, x plus 6. The product of x and 7, it could be 7x. The sum of q and 8, q plus 8. 6 squared, 6 to the power of 2. Twice q is 2 times q. The product of 8 and 12 is 8 times 12. The quotient of 18 and n would be 18 divided by n. N cubed is n to the power of 3. And now we have to write it as verbal expressions. Usually writing algebraic expression to verbal expression would be harder for me, personally I feel like, than writing verbal to algebraic. So x over 2 is half of x. 8 plus 9, sum of a and 9. 19 minus 3, 3 less than 19. Now that the order is swapped, 5 times n, product of 5 and n. Q squared is q squared. 40 divided by 5, simply 40 divided by 5. And the quotient of a and 8, x plus 8, n minus 14, or the difference between n and 14. 2 to the power of 2 is 2 squared. 60 divided by 5. The product of n and 6. And now we have to actually solve these expressions, so we have to we need to evaluate these expressions. 5 squared is basically 5 times 5, which is 25. The product of 8 and 10 is 8 times 10, 80. 20 decreased by 17 is 3. Quotient of 96 and 8 is 12. Twice 6 is also 12. 10 less than 17, order should be flipped, so it should be 7. 9 times 5 would just be 45. 10 increased by 8, 10 plus 8, 18. 7 squared, 7 to the power of 2 is 49. The product of 4 and 5 is 4 times 5, which is 20. And that's it for our first lesson of verbal and algebraic expressions.